Alright, we're looking at page 65, which is the warm-up for the quiz you're going to take today. Let's go ahead and jump right in. Number 1 asks, what's another way we express temperature? And, I mean vocabulary. So another way we can say temperature is average kinetic energy. Remember that temperature is actually not a measure of heat, it's a measure of motion. So average kinetic energy, where energy is the measure the energy of motion. Average kinetic energy is another way to express temperature. Number 2, what happens to the volume of a gas if pressure decreases? To answer questions like this, you may want to remember our little PTV trick, where if they tell you something's constant, that's where you put your pin, and then they ask what happens to the volume if pressure decreases, so you turn your page so that pressure goes down, and we see volume going up. So volume increases for number 2. For number 3, what happens to temperature if volume increases? They're asking about temperature and volume. Pressure is constant, so that's where I hold my pen. If volume increases, I turn my page and temperature is also increasing. For number 4, what happens to the pressure if volume increases? They want to know about pressure and volume again. Temperature is constant, so that's where I hold my pen. They say volume increases. I turn my page so volume goes up and pressure goes down. So pressure is decreasing. This next problem is a stoichiometry problem. If the combustion reaction below uses 7 liters of propane at STP, how many grams of water are formed? A problem with liters and grams is going to be a 4 fraction problem. So we're going to start all the way at the left so you don't run out of space. Take the given 7.0 liters of C3H8 over 1. Remember, whatever that given is where we're going to start our mole bridge. And they're asking for grams of water, so I'm going to point my bridge over at water. Then I do what goes up must come down. That uses liters twice. I can't use liters again. I need to switch. So, as always, we're going to switch to moles. Remember that when moles and liters are together, you're going to be using 1 mole and 22.4 liters. Then we do what goes up must come down again. Moles of C3H8 come down. And remember, when moles are at the bottom, that's your signal that it's time to use your bridge. There's no number in front of C3H8. That implies we should be using 1 C3H8. And my bridge is pointing to 4 water. But not just 4 water, 4 moles of water specifically. Then what goes up must come down again. That uses moles of water twice, so we need to switch once more. We're going to switch to grams this time, grams of water. When grams and moles are together, we use 1 mole, and the grams come from the periodic table. If you check your periodic table for 2 hydrogens and 1 oxygen, hydrogen is 1.008, oxygen is 16. And that all together adds up to 18.016. So that's my number of grams that I'm going to put here. Then we put it in our calculator, top times top times top, divided by the bottom. You don't really need to type times and divided by 1 every time. Altogether, this gets 22.52 grams of water. Let's look at number 3. Number 3, if you have 0.56 moles of neon gas at 23 degrees Celsius and 1.5 atm, what volume would the gas occupy? So let's copy our givens down. 0.56 moles is a given. Our variable for moles is N, so we're going to label that N for moles. At 23 degrees Celsius, so that is a temperature. We're going to label that T for temperature. And 1.5 atm, that is a pressure. We're going to label that P for pressure. They ask what volume, so V, volume, is our unknown. We only have one of each variable here. One in, one t, one p, one v. When there's only one of each thing, there's only one possible equation to use. There's no changing. I don't have n1 and n2. I don't have t1 and t2. I don't have v1 and v2. I just have one of each. So we're going to use this equation, pv equals nRT. Pervnert, as I always call it. Notice this R in Pervnert. We need to pull that off of our formula sheet as well, 0.0821. And those units of R are telling us that we need to match our other units. So R is 0.0821 liters times atmospheres over moles times Kelvin. Yes, I will write that on the board during the quiz. You don't have to memorize it. These crazy units are here for you to match your units. So they're telling us like pressure needs to be atm, which it is. We need moles. And we need Kelvin. This temperature is Celsius. We need Kelvin. So we got to change this by adding 273. And then we don't need the Celsius anymore. Notice this set of units also tells us what the volume should be. This uses liters, so our volume needs to be liters. And that means our answer also needs to be liters. From here we can plug everything in. Instead of P, I'm going to use 1.5. We don't know V, so that's going to stay as a variable. Equals N was 0.56, R is 0.0821, and T, make sure you use the Kelvin, 296. To solve this, I recommend first you simplify the right side just by typing that into your calculator, 0.56 times 0.0821 times 296. So then we'll get 1.5 V equals 13 you don't really have to write every single digit, but 608896. To solve for V, we need to isolate V by moving the 1.5 over. 1.5 is being multiplied. Do the opposite to move it and divide. So that what you're actually typing in your calculator is this, and you get 9.07 liters as your answer. Finally, for number 4, a mixture of 3 gases, water, helium, and nitrogen, is at a total pressure of 4.5 atm. The partial pressure of H2O is 1.68 atm. Partial pressure of helium is 1.3 atm. What is the partial pressure of nitrogen gas? There are several key words in here. Mixture, partial pressure. They say partial pressure like 3 times. Some of these key words should make a little bell go off in your head. Ding, 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 ding. When you see any of these key words, that should tell you for sure, 100% positive, you're going to use this equation in your guess boxes. This is the equation you're going to use. So we could copy that over right now. P total equals P1 plus P2 plus P3. It keeps going depending on how many gases are in your mixture. If we check the problem, it says water, helium, and nitrogen. So there are 3 gases in the problem. That means I need 3 pressures in my equation, which conveniently I already have. From here we need to just mark down our givens. It says a total pressure of 4.5 atm. So make sure you label that P total. The others we can just number. 1.68 atm will be pressure 1. 1.3 atm will be pressure 2, and they're asking for the 3rd partial pressure, so that can just be pressure 3. Because these given pressures all have units of atm, our unknown should also be atm, and our answer should be atm. From here, we're just copying and substituting our numbers in. Instead of P total, I'm using 4.5 equals P1 was 1.68 plus P2 was 1.3 plus P3 we don't know. The easiest way to solve this problem is to first simplify. Combine like terms, 1.68 plus 1.3. So 4.5 equals 2.98 plus P3. And from here to solve, we're just going to subtract 2.98 to get our final answer. Feel free to do this in your calculator. No one is asking you to do this by hand or in your head. You get 1.52 ATM.